Thank you, everyone, for attending this session. I know this is kind of between you and your flight, so thank you very much for sticking to the end. Today we are going to talk about cluster inventory. And my name is Ryan Zhang, and I'm a software engineer manager in Microsoft.
And I'm Corentin Debains. I'm a SWE at Google, working on GK.
So previously on Sig-multicluster, we have talked about this ClusterProfile API multiple times. This CAP was initially started in 2023 in October, and we had our first talk in KubeCon EU 24 in Paris. At that time, that CAP was just merged, so we kind of very enthusiastically announced this new shiny API to the world. We got some good feedbacks. And then fast forward to the next KubeCon in Salt Lake City. At that time, GKE and Azure both start to officially support ClusterProfile. So if you go to GKE or Azure Fleet, you will see the ClusterProfile there already. So at that time, we have this, probably you cannot see the title, but it's called One Inventory to Rule Them All. However, there are some hiccups. It's not ruling yet, but we keep it on, and we have 2 more talks in this year's London EU KubeCon. And just to refresh everyone's memory, or for those who the first time, so the ClusterProfile API is a Sig-multicluster sponsored community-driven API. It is a CRD, it's a namespace, a CRD. The main purpose is for any fleet to describe their inventory in a standard way. Because we have a lot of cluster managers in the community that they all have their own way to describe their inventory. So the idea is that let me see. So you have your cluster managers, OCM, KubeFleet, Kamada, and Armada, or all these. They all have a way to describe that, but we now have a community-driven standard way called a ClusterProfile. So those managers will emit those profiles, and then you have multi-cluster controllers like Argo CD, like multi-queue, multi-cluster runtime. They will consume the same standard ClusterProfile from all these managers. So they don't have to switch, have different implementations for different cloud managers. And then with this ClusterProfile information, they get to understand what are the clusters they have in this. That's why initially it's called a cluster inventory. So you know what's the clusters in your fleet, and what are the properties, and how do you work with them. Yeah, as I mentioned, that it's not inventory to rule them all yet. There are potentially 2 big blockers. So first thing is more technical reasons, is, as I mentioned, it is supposedly you can use that ClusterProfile to manage your cluster, but in order for you to manage your cluster, you need a way to actually access it in a secure way. All right. So currently, if you are familiar with, look at our ClusterProfile, initially there's no credential information there. So you only know what are the cluster in your fleet. You kind of can have different ideas, shapes and the size of these clusters, but you cannot actually do a lot about that. So we definitely need a way to bridge the multi-cluster controllers to the clusters through the ClusterProfile API. However, the problem is not as simple as just slap a token into the ClusterProfile API and then call it a day, right? Your security guys are going to scream at you, and it's no fly anywhere. So that's a little bit tricky. That's why it took us another year to get the second talk to tell the community that we kind of have solved that problem. So that's a bulk of our current this talk. And there's another kind of typical problem when you want to propose a standard API is there's a consumer side and then is the producer side. So it's a chicken and egg problem. You kind of need to get both sides to start to roll. But initially you don't have either side. So which side do you go first, right? So you need to have enough producers that support this standard, and then you have enough consumers that consume this standard. And the more consumers, the more incentive for the producers to produce, but also the more producers, the more incentive for the more producers, the more incentive for the consumer to consume that. So we are kind of in this bootstrap phase, and we are also going to, in this talk, we'll briefly report what's the current progress of this process. Yeah.
Yeah, so let's focus on the first part that Brian talked about, the credentials and cluster access. So first problem we had, and we knew from the get-go we had to solve that problem, and here we are, here's our proposal that we pushed and that hopefully you'll like. So really the requirements we had to be happy for a solution, we want to be open source, so allow anyone to write plugins that can help exchange some information and get a token, build a REST config so you can access the cluster. So open source, anyone brings their own plugins, so that means it cannot really be baked in a repo. It cannot be in some code that's always there, like that you have to go. So no centralized management. So really open. The second step is we wanted to allow the community to write controllers without having to know about the plugin ahead of time. And that kind of goes back to the previous point. If I'm a controller writer, I want to be able to write my controller, put it in the wild, and let a big company or a small company doing their own access control, access method, and still leverage my controller without having to recompile, get a different image, things like that. So that was a pretty important thing for us. What we came up with was to look at what kubeconfig does. That was a big source of inspiration for us, what SIGAUF built for kubeconfig with their pluggable model. If you ever open the kubeconfig, when you look at the cluster section, or is it user section? One of those. Yeah, there's this exec that tells you, here's the binary you need to exec, here are the arguments, and here's the cluster info you can pass to it. We took the exact same approach. We actually leveraged the protocol from the kubeconfig. We took the two parts. One side is the cluster, the other side is the plugin. So if you look on the right, we got this guy. We have the cluster profile here with the cluster access defined. That would be what the cluster struct is, so that's usually the endpoint, the CA, things like that. We'll see that in a little bit more details. And at the bottom, there is the plugging definition, so what command to execute, which arguments to pass, which environment variables, things like that. The controller sits in between. And the controller knows about the plugin, knows about how to run them, and has them available to it. And at the same time, when it reads the cluster profile, so dynamically created cluster profile by your cluster manager, it'll know from the cluster profile what kind of plugin it expects to run and more details about the cluster that can be used to build the REST config. So this is like the two parts that we took from the kubeconfig, and we put all that in that KEP 5339 that's now merged and is the standard now for doing cluster profile access. So this is kind of the high level, and sorry, there's going to be a lot of text. Hopefully not too much. So on the left, we have our cluster profile. We have two examples of it, one being like the GKE one and a kube fleet one. So you can see it's very simple, no secrets, stuff you'd see in your kube config normally. I mean, the endpoint, which is an IP here, and the cert that's going to be validated, like the authority, your CA here. Same thing on the Azure side. And what's important is the name of the provider. Here it says Google, here it says Azure Fleet Manager. That's what you're going to have in the cluster profile. That's it. There's no local credentials, there's no secret. It's all portable, it's safe, not a problem. So now, how does the controller use it? The controller on its side will have some config, so not checked in, not in the code, it's all config you can pass at runtime. It'll tell what command to use for which provider. So for the Google provider, it says, okay, this is the GKE Cloud auth plugin that you'll exec. You'll recognize the kubeconfig one. It's the same protocol, so it uses the exact same one. That's a super cool thing for adoption. If you're already doing things for kubeconfig, you may be able to lift and shift. Similarly for Azure Fleet Manager, so that's our provider name, you'll run kube login and you'll have a little bit more arguments because it takes those as parameters, where the Google one takes more as an environment variable. Like in your environment, it reads like predefined locations. So very, very similar to what you have in your kube config. And one of the nice things is also your controller can support here an Azure and a Google cluster. So you could have a mixed mode fleet with clusters coming from Azure and Google at the same time. You put them in the same fleet, they'll mix, and because of the provider name, it'll know how to get credentials. So that's the little protocol for that in config. In the code, how are you going to use that? Is really two new things. So the credentials provider is that big config file that we saw. So read that as a flag, pass it, build a kind of a credential structure object. And then whenever you get a cluster profile, we're reading cluster profile, but whenever you get a cluster profile, you can pass it and exchange, build a REST config via the cluster profile based on your credentials, on your providers. It's really simple. And the nice thing you get from this is that you put it in your controller and that's it. There's nothing else to really do. You don't have to recompile if you knew new platforms or new credentials access.
Just to reiterate that this whole code, actually the magic is happening here. This is a library that this community will already build out this library. These yellow lines are just calling this library. You don't need to do anything. It's just call this library. So it's simple as call some libraries. You get this credentials, get providers, you get your REST config. Then you can talk to your clusters.
Basically, just copy paste this. It'll work.
Yeah. No. Yeah. Exactly. And Corentin will give you another example after that.
Go for it.
Yeah. So now we want to kind of report the progress on the second problem, right? How do we, how's the progress in the community of adoption and supplies? I think, again, we are happy to announce that GKE has official support for this ClusterProfile plugin, not just ClusterProfile, but this access plugin is configured. So I think now if you go onto GKE Fleet, you can have this access. And the Kube Fleet on the Azure side is having, I think we uploaded this doc, you can see the CR, the PR is actually actively working on. There's a few small glitches need to fixed. So I would say that within this calendar year, you would be able to use Kube Fleet to do the credential plugin too. And on the OCM side, they have actively discussion and plugin working on that. OCM is actually one of the original sponsor, and a lot of ideas are coming from the OCM community. So I'm pretty sure they're going to support this very soon. And on the consumer side, again, we're very happy to report that the multi-cluster runtime, they have already integrated ClusterProfile with this access control plugins. So now if you use a multi-cluster control runtime, it will automatically and you have cluster working with a cloud provider like GKE that has a ClusterProfile plugin. It would already work, and Corentin is going to give you some tutorials to show how it works. And Argo CD and multi-queue are both having active ongoing issues. On the multi-queue side, there's an active PR going on. So I think it's getting there. And more importantly, especially for this room, like if you have a multi-cluster usage, if you are running a controller that needs to talk to multi-clusters, and you don't want to integrate with, pick different cloud providers or cluster managers, please look at that libraries I just showed. Just import that library and copy paste the code here, and you are like 90% way there. Corentin is going to give you a more detailed step-by-step tutorials on how to write that controller.
All right, so as Ryan said, so let's pick ClusterProfile with our exec library, kept implementation, and we'll take multi-cluster runtime as our example. It's pretty popular way right now to write multi-cluster controller. It's very similar, you'll see, to the controller runtime. So there's a lot of issues and PRs in this repo, and it's pretty exciting. So have a look at it. And so I'll show you how to create a multi-cluster controller with ClusterProfile. First step, writing the controller. Here's nothing new if you're familiar with controller runtime. If I start at the bottom, here the one I'm writing is just a little config map reader across my entire fleet. It's not really useful, but you'll get the idea of whenever there's a config map, we get a reconcile request, and we can just log it as that. The really interesting part here is we're creating same thing, like same library as before, recreating the provider config, get a provider, pass it to our multi-cluster manager as the provider of clusters, and like everything's wired under the cover to get whenever a cluster gets added and removed, it picks it up, adds the watches and all that. That's all the multi-cluster runtime beauty. And then, so basically, as a writer of a controller, this is the only part that you really end up writing that's proprietary to your controller. The rest is all like boilerplate that you can just lift off the open source community. Now, the controller, building the controller, this is kind of a simple step. You all know about everything, but I just wanted to point out the exec. The providers that you're going to want to exec, you need them in your binary. So putting them in the Docker file as a multi-stage build in Docker is kind of an easy way to do that, getting them there. So if you have your Google image where the plugin is and the Azure one where the plugin is, you can like easily get them there. You don't have to recompile them, or you can modify your images to make it too complicated, or apt or package installer. That's a nice way to get them. An alternative to that is to mount them as volumes, but binaries as volumes is always weird, config map volumes. But that's a little interesting way. This you might already be familiar with, but setting up your fleet. In GKE especially, it's going to be like that. You're going to be creating your clusters, putting them in the same fleet together. You'll say this one is going to be my hub cluster, so my central cluster where I'm going to run my multi-cluster operations. And you just have to label it in GKE, but I'm sure there'll be alternative in other platforms. And as a result, all the cluster profiles are maintained in there. So that's how you get your cluster profile written and synced following the memberships in your fleet. The other thing to talk about is permission. That's maybe the hardest part once you get there. So imagine you've written your controller, you've deployed your pod, and it's running on your hub cluster. You got your cluster profile, it's reading it. What do you need to set up in terms of permission? That's not that easy. The first part, well, it needs to read cluster profile, so there's a little local RBAC that's necessary. This one's not too bad. The rest here, often and obviously, is where it gets a little bit more complicated. So when the controller here execs and gets credentials, it gets credentials under a certain name. In the case of GKE, we would use workload identity. That's a recommendation. So you have a GCP workload identity string. And so you need to write a rule to allow this particular service account, that portable service account name that you got from your credentials, to say, okay, this controller, yeah, service account can access the other clusters. So that's your often, they need to recognize it. So in GKE, that would be an IAM rule to allow connection, the get credentials part. And then the last part is accessing the objects inside of the cluster. So in our previous example, we're doing config maps. So here we would want either potentially an RBAC with the same name used here, like whatever this cluster will see as the name of the service account from our controller, to access the config map, so read, watch, get. In GKE, the interesting thing is you can actually make it an IAM rule, and that way you get all the clusters covered. You don't have to write individually IAM, but this is the obviously problem. How do you access the object specifically for your controller? So those are not fully solved problem. I think there's still a lot of things to figure and to set up, which is not easy, but we're actively looking into this problem, and can we help with some automation there? But given its security and rules, your security folks might want a custom path here, so that's maybe where you end up. All the code is available here as the example, so it works. It's cool there. I actually have a version of it working that I can show. That way, since we have a little bit more time and the Wi-Fi is okay. Let me see if I find it. How do I exit? There you go. Boop. It's not there. Oh, okay. Let me get back here. All right, I'll look here. So this is an example of the controller I just showed you, but actually running on a GKE fleet of clusters. I got a hub cluster and 2 member clusters. And let's see what they look like. So my mouse is here, yeah. So this is my hub cluster and my 2 clusters. They're all in the same fleet. And I've labeled this cluster as the fleet cluster management cluster, fleet cluster inventory management cluster true, which turns on in GKE the synchronization of the cluster profile and all set up. So that's all I had to do for the cluster manager side. So let's get on the controller. All right, let's okay, we're here. So I got credentials for kubectl to be, if I can type, I'm on the hub cluster here. So if I get cluster profiles minus all name spaces. So those are the 3 cluster profiles that were written by GKE. Let's just quickly look. Is that truncated? Sorry about that. Boop. So you can see the credentials provider in the status of the cluster profile. It's just a server you can access. As a controller, you can talk to that, and they'll say Google. Let's look at the controller now. So I created my controller and deployed it in the default namespace. Don't do that in prod, but this is my controller, and you can see log. Oh, come on, it's logs. So it's been reading from all the clusters, just the config map. It's not really complicated, but it's a lot of wiring. The only thing I'm not showing here are the IAM commands. I actually have them. This nice makefile here. I mean, this is all under the cover. You're seeing everything behind the thing, but where's my mouse? Here. Log a few commands to add IAM. So you need container developer, what is the obfusc part, what gives me access inside of the cluster. And the gateway editor is what gave me the access to the cluster, so more the authn. And that's it. I'm using workflow identity on the cluster. I didn't show that, but like it's enabled by default on autopilot, so you get that and it just works, which is, and remember the workflow identity I was talking about, this is the username of it that the cluster sees. All right, that's that. Let's go back to the presentation. Yeah, sweet. Yeah, go for it.
Great. Hope you enjoyed the demo and all these copy-cuddle command lines. I wish we can see more in these talks. So now we kind of solved that credential problems. The next thing is about properties, right? The cluster profile, when we started, we were thinking about using them as way for the multi-cluster controllers, especially nowadays schedulers, to schedule your precious AI jobs to different clusters so that you can get the maximum out of your GPU resources. But without all the nice properties, it's still some way to go. So we would really need more community voices, community input into how we can add properties, especially what type of properties are useful. So the ClusterProfile API itself is actually very open. So anyone, if you want to implement that, you can add your own properties. But we are looking for some community-driven properties, like standardized. Again, the key for the Sig-multicluster is to interoperability. So we want some standardizing there. And also the same thing about, as Corentin mentioned, that currently we kind of just bake the plugins into the Docker files. That works, but we are not 100% sure if that's going to be the standard way to go. So we also want to hear from the community, how do you prefer to do that? And the third one is definitely for us, and maybe the community can help, is improve the documentations. Right? We for plugin for a standard API to get popular, we definitely need a lot of good documentation so that they don't have to come to listen to a talk to understand how does that work. So we need documentations, examples, plugins, maybe there's a plugin registry or something so that they can have all them together. Integrations. Yeah, that's kind of the next steps we're looking for. And again, thank you very much for coming to our talk. We are looking forward for you guys in the Sig-multicluster channels or course. We currently have weekly course in the US and US friendly time zone and bi-weekly time in Asia Pacific and the EU time zone. So thank you very much. I think that's.
Thank you.